Now 7.16. From a uniform disk of radius capital R, a circular hole of radius R by 2 is cut out. The center of the hole is at R by 2 from the center of the original disk. Locate the center of gravity of the resulting flat body. See here, as shown in the figure, the disk that is with mass capital M and radius capital R. Now, see here, consider a small disk having radius R by 2, and this will be cutted from it. So here we can say this thing, our original disk is made by two constituents. One constituent, that is this small disk having radius R by 2, and other constituent, that is this remaining part. Now consider the center of mass of the original disk, that is at the origin of coordinate system xy. Now the center of the small disk having radius R by 2, that is at a distance R by 2 on x-axis. Suppose mass of that small disk is m1 and mass of remaining part is m2. Now we want to find the position of the center of gravity for this remaining part if this small disk is removed and hole is made at that place. Now see, first of all, we can write RCM, the position of the center of mass of original disk, means of the system. That is equal to M1 R1 plus M2 R2 upon M1 plus M2. But RCM, that is 0, 0, because it is at the origin. So 0, 0 equal to M1 R1 plus M2 R2 upon M1 plus M2. Now take M1 plus M2 on left hand side. So we can write M1 R1 plus M2 R2, that is equal to 0, 0. Now M1, mass of small disk, R1, position of the center of mass of that small disk, M2, mass of remaining part, R2, that we want to find the position of the center of mass of remaining part. But masses we don't know. So first of all, we have to calculate M1 and M2. Okay, now let's first calculate it. Mass of the disk given to you, capital M. Radius of the disk, capital R. So area of the disk will be pi r square. Now mass per unit area of the disk, that is total mass upon total area. So m upon pi r square. Now simple unitary method. Mass of unit area, that is m upon pi r square, then mass of the area of this small disk is how much? So m1, that is mass per unit area m upon pi r square, and area of this small disk, that is pi into radius r by 2 whole square, so that is r square by 4. Pi r square cancelled. So m1 will be m by 4. Now r1, position of its center of mass, that is on x-axis at distance r by 2. So we can write the coordinates r by 2 and 0. Now mass of remaining part. So this mass m1 is cutted and taken out. it implies that remaining mass M2, that is capital M, and from that M by 4 is removed. So M minus M by 4, that is 3M by 4. And suppose position of its center of mass is at xy, that we want to find. Now substitute here these values. M1, M by 4, R1, so coordinates R by 2 and 0, plus M2, 3M by 4, R2, xy, that is equal to 0, 0. Okay. Now take M by 4 common, take it on right hand side, will be cancelled. Now compare x and y coordinates on both the side. So here x coordinate r by 2 plus 3 into x, so 3x, that is equal to 0. Then y coordinate 0 plus 3y equal to 0. So y coordinate will be 0. Now here r by 2 plus 3x equal to 0. Therefore 3x equal to minus r by 2. Therefore x equal to minus r by 6. Therefore coordinates for the position of center of gravity of the remaining part is minus r by 6 and 0. Clear?